Hello, everybody. Hello, Berlin. How are you doing? Welcome to this session. We'll be talking about Alexa and how to build your first voice experience. You will see how to make an Alexa skill. Let me introduce myself. I'm Benoît Chawati. I'm a solution architect for Alexa, and I'm based out of France, and I'm dedicated to Alexa Skill Kit. But before beginning this session, maybe I want to ask you a question. Who has already been using Alexa? OK, that's quite good. Who is using Alexa on a daily basis? OK, should be good enough. And who already built an Alexa skill? Great, you've got my greetings. That's very good. So we will see how to build an Alexa skills. And before I exactly see how to make an Alexa skill, first of all, we will look a bit step forward and to appreciate this magic moment in the sense that every decade there is a new technology coming in which completely changed our lives. If we think previously, the web entered a new space. Then after, mobile and touchscreen enter a new space. It means that people that interact with technology find new ways to make businesses and to make applications based on this technology. Now, this new era will be based and is based on voice. And why? Simply because we believe that voice is the next major disruption. Why? Simply because voice is a human interaction, which is natural to everybody. From the moment you've been born, you've been using voice. So it's not a new technology that you will need to learn. It's something that you already know and something that you will use to connect with technology. And it will change the way you access it, the way you will build businesses, the way you will build new startups, for example. So that's why we believe that voice is the next major disruption. Once we have said that, the thing is, we've got Alexa. OK, so what is Alexa? Alexa is a cloud-based service. This brain sits in the cloud, in the AWS cloud. That is where the magic happens. But to connect with this cloud-based service, you will be using devices. And to use devices, actually, you can use devices from the Amazon Echo family, but also you can use devices from third parties. To ensure that devices can connect to Alexa, and you can embed Alexa within these devices, you will use Alexa voice services. It will allow you to integrate Alexa. And if we look today in the different devices that are available out there, that is all the Alexa-enabled devices, you can find them in fridges, you can find them in cars, you can find them using Amazon devices from the Echo family, with or without a screen, for example, using an Echo Spot or using an Echo device. So actually, when you are integrating Alexa within a device, you only need three things: a microphone, a speaker, and an internet connection. That is only the three things that you really need. Why? Because simply all the brain sits on the cloud. And when you can access Alexa from within these devices, you will be able to access different skills. Today we have like more than 40,000 skills out there. And the different type of skills will range from to get a ride, will get information, will get content, will get music. So you will have the ability as a developer to build your own skills. And the thing which is interesting when you build your skill is actually the skill is not within the device itself. The skill is within the cloud. So it means that if you remember the previous slide, all the different Alexa-enabled devices that you've been seeing, you will be able to access all these different skills from all these different set of devices. And actually, to do a skill is pretty much like building an application on a smartphone. That could be the parallel that could be made. And to do that, you will use what we call the Alexa Skill Kit. The Alexa Skill Kit is a set of tools and self-service API to allow you to build a skill. And as mentioned before, you've got a lot of skills out there that are already available. You simply need to activate them on your account and use them. So when we have a bit more of an idea of what Alexa is, what a skill is, actually the goal here is to create your first voice skill, your first Alexa skill. So if we look about what an Alexa skill is, well, actually, it's pretty much made of two things, two major things that we can see pretty much like a front end and a back end to relate to some stuff that you might be more aware with. First of all, you will describe your voice interaction on the first part. The second part here, at some point, you will define your programming logic. That is where you will define the behavior of your skill. You will first define your use case. For example, you would like to ensure that you will provide some content related to sport news. So in that case, your backend will connect to Sports API, for example. But let's look first on the voice user interface. The first user interface is something which is a JSON file that we will see a bit later on, which can be deployed on the developer portal, developer.amazon.com. But also you can use this GUI, this console, the developer portal, to create your very specific interaction model. That is where you will be defining the invocation name, how to call your skill. That is where you will be defining the intention, the different use cases you want to cover. That is where you will define the utterances, the different phrases that will be used by Alexa to recognize the different intent. And that is where you can define some attributes that we call slots. Then after, for the programming logic, at some point you will receive a request from Alexa within your skill. It will be a JSON request. And to process this request and answer to Alexa response, actually, you can be using AWS Lambda. I'm pretty sure you're very familiar with the serverless AWS service, which will allow you to, out-of-the-box scale, be fault-tolerant, highly available, only pay per use. And the key thing is you will only look after what you want to achieve, what is the logic you want to implement. So that's why we always recommend to use AWS Lambda. But the thing is, you can also, if you'd like to, just host your backend, this logic, on an HTTPS endpoint, a public one, which follow a set of requirements. So actually, within AWS or outside the world, this can be possible. The most important thing to think about is to receive a JSON request and answer a JSON response. So if we look a bit more into detail about what the Alexa Skill Kit is, how you will be able to use this framework to build a skill, it's actually something which is quite interesting here to notice is you don't need to be a data scientist. You don't need to be a natural language understanding expert. The thing that you need to care about is to provide the voice user interface and the programming logic. The magic then is made by Alexa. So we will look into more detail about the different phases that happen when you say something being an utterance to Alexa. So first of all, of course, you will invoke Alexa. So to invoke Alexa, you will use a wake word. The wake word can be Alexa. It is the default wake word. But you can also choose another wake word. For example, you can choose Echo, computer, or Amazon. So actually, on the device itself, there is a wake word engine, and this engine has only the responsibility to listen for this wake word, and once this wake word has been called, it will stream up to the cloud the audio you've been talking to the device, the utterance. So once the audio starts streaming, actually, what you've been saying, that we will be calling an utterance, will be processed by Alexa. And once this utterance is processed, it is where the audio is transformed to text. Then after this text, it is recognized and transformed into intentions. Those intentions are the intentions that you have been described previously on your voice user interface. You will have defined a backend skill. So actually, at the end, if we look on the right side on the slide, your skill, meaning your service, your backend service, will actually receive a JSON of what is the intent with a lot of different parameters. So once you want to speak to Alexa, if we look into more detail, you will have the wake word, first thing. Then after, if you'd like to call a skill, you will have the launch word. For example, here you can have open. But as you can see here, there's a lot of different launch words that can be used. For example, start launch, and pretty much others. And afterwards, what you have is that you will have the invocation name of your skill. What is the name you have provided to ensure that an end user can invoke your skill. And that forms an utterance. That is one way to call a skill. But also, when you speak to an Alexa device to access to a skill, we have seen previously that we can launch a skill, but also we have what we call one-shot utterances. It means that within one utterance, you can directly access to the intention you are looking for an answer. For example, here in these specific cases, Alexa asks Restaurant Finder for breakfast. So here you have the wake word. Then after, Alexa will stream the rest of the utterance, which is lunch, skill name Restaurant Finder, and your skill will receive an intent which corresponds to the intention mapped to the utterance for breakfast. And that is where on your voice user interface, you will define different utterances to be mapped to the intention for breakfast in this specific case. But also, I've mentioned before, we can also have some attributes that we call slot. Let's say, for example, you want to add a little bit of dynamic, not resolution, but way of getting parameters, and you'd like to have a recommendation for a specific restaurant within a distance. Distance could be a range of different miles. So in that case, you want to collect this value within a slot. Say that a slot is just an attribute. So you define a slot within your voice user interface, and then afterwards, when someone within a utterance mentions this slot, for example here, recommend a restaurant within 4 miles, actually, your skill service, your backend, will receive the intent, recommendation intent, which is the purpose of what the user wants, and will also receive the slot with the given value 4. So when a skill actually receives this value, it means actually at the end that the intent is sent to your service. This AWS Lambda function or an HTTPS endpoint. And that is where you will process this intent and provide back an answer to Alexa. We will see just a bit later on that we do provide some SDK that you can integrate within your backend code to accelerate the development of your backend skills, which is the Alexa Skill Kit SDK for Node.js or Java, for example. So far, you received a JSON input from Alexa. You will process it and return an answer. Same thing here, you don't need to handle or be an expert in voice recognition or to send something which is a voice content. The thing is, you only need to return the input text that you want Alexa to say for you. But also you can add some different, not behavior, but surprising or different element that will delight customer by using SSML. SSML, for example, will allow you to add some speech count, will allow you to change the intonation on some part of your utterances. So that is where you specify actually to our text-to-speech engine what you want Alexa to prompt from your skill. And once this prompt is processed, it will go back on the device where the end user will hear this input. So once we have said these different things, I want you maybe to make a little demo about how to create a skill. Would you like to? Okay, let's do it. Okay, so up. Let's see what's happening on the screen. It's not that good. Okay, so here we've got the Alexa console. Not exactly the Alexa console, it's more exactly the Alexa Skill Kit console that you can find on the developer.amazon.com portal. That is where you can create skill. So just in case there is a demo issue, I already have a skill set up for you, but we will create one for you. So here we will use a command line here, where actually we will be creating a skill using the CLI, the command line interface from the Alexa Skill Kit. All you need to do is to install this CLI on your machine. Of course, to be able to use the AWS Lambda services, you also need to install the AWS CLI. So that is what I've already set up. And actually, to correspond to the different slides that we've been seeing regarding the fact that we want to have a recommendation for breakfast or for an activity, actually, we will create a new skill using a template which is called City Guide. And to create actually this template is as easy as using the CLI, which is ASK, which is the CLI. New, I'm using a profile and some templates. So I would create actually here Alexa skill on my computer. So the City Guide skill has been created. So let's have a look at what it looked like. Okay, so here on the left side here, what we can see is all the different files that have been created. If we relate to the slide of what you need to create for an Alexa skill, which is the voice user interface and the AWS Lambda function, where actually it is available there. Well, actually here we can see that we've got models and that we've got Lambda. Okay, so here actually I want to create a multi-local stream, one for UK and one for United States. So for example here, let's make it a little bit bigger. So here it's the JSON file I've been talking to you regarding the GUI, the interaction model that you need to upload to the developer portal. So actually what it is contained of, there is an invocation name, how to be able to access the skills. You will define some intention, which are called intent. Each intent will have a name, and the different samples are the utterances we've been talking previously. And at some point here, if we look at the attraction intent here, we do have some samples, utterances, that will be used by Alexa to ensure you will be able to recognize the right intent. We can see that there is an attribute, which is a slot. And in that case here, when I've been telling you that I want to gather or to collect the distance information from an end user, actually, that is the way I will be doing that by specifying a slot. So I want to gather a number, which is a predefined slot from the Alexa developer portal, from the Alexa skill kit, sorry, which is an Amazon.number. So actually, Alexa do provide you for creating a skill some pre-built slots, for example, for number, for names, for city, for country. All you need to do is to specify them. Of course, if you want to create your custom slot with a lot of different values that comes from your use case, you can also do that. So that is for the interaction model. Invocation name, intent, sample, slots. That is where you define it. Then after, actually, at some point, you will have an AWS Lambda function. So here, actually, I've been talking previously about an SDK. Actually, we do provide an SDK to ensure that the only thing you need to concentrate on is to really make your code logic. You don't need to ensure how you will process the requests you will receive and how you will build the response needed by Alexa. So actually here we have an SDK, and this SDK is SDK version 2, so that is where you define it. And at some point here, in this new SDK, actually you will be able to define handlers. And within these handlers, the thing is, there is a canHandle method, which is actually quite neat, because it will allow you to know whether this handler will process the request you will be received. For example here, when we will say, Alexa, open my skill being the invocation name. In that case, if I receive a launch request, this handler will process it in the handle method. So you define the different handler here that correspond to the different intention that you want to provide from the user. And at some point here, at the end, of course, you will here instantiate this Alexa SDK. So when you instantiate it, you will provide other different request handler. And also there is one thing I want to modify with you, which is the interceptor here. Well, actually, when you are doing some debugging here, thing which is good is always to gather the request and the response that has been received by a skill backend. So here, actually, what we will do is that we go back there. I'm sorry. We go back at the end of the file. Here I do add these two handlers. I already have a request interceptors, which will allow me to intercept the request. And actually, what I want to do is to add a response interceptor, where here, actually, I will be adding the response log. It will allow me to, here it's simply console.log. It will allow me to input within CloudWatch logs the incoming request received by your skill, but also the outgoing response the skill has been providing to Alexa. So it's something which is neat, and I like it on a daily basis to do. One last thing is the skill metadata. At some point on your skill, you will define whether the skill is multi-local or not. So you will define here the different locales that your skill will be supporting. So here we are supporting ENUS. And for example, as we already have the interaction model for ENGB, what we will do is simply to ensure that we will be able to also use this skill on a different locale. So on here, you will define the different locales, the publishing information, and also the Lambda code that will be deployed on AWS. So once we've made this different modification here, we simply go back there, and we say, actually, oops, sorry. I should be in my Citiga, okay. I should actually deploy, I want to deploy this skill, meaning the voice user interface and the skill metadata on the developer portal, and I want to deploy the AWS Lambda function on my AWS account. So to do that, I only need to do ask deploy with my profile defined. So that is where actually it will be deploying the different artifacts. Now, we can see that right coming on my developer portal there. Let's refresh it and see if it has already happened. Great. You can see that a city guide skill just bumped in. And within this city guide, you can see that two locals have been mentioned, English UK and English US. And actually, if we look at the skill itself from the developer portal here, we can see that the interaction model that we have been specified previously on a JSON file is available right there. And you can modify it from this console here. We can see that we have the invocation name, we have the different intent there, the custom intent here, but also we have the built-in intent, and actually the slot that have been defined. Of course, if we look at the JSON editor here, you can still have access to the JSON version of the file, modify it, save the model and rebuild it. Yes, one thing to keep an eye on, it's not because you save an interaction model that you will get the latest version built and available from your skill. You need to build your model to ensure you access the latest version. So here we can see that when we have been deploying this skill with the ask deploy command, actually, by default, it will already build the skill for you, and it will enable the skill on your Alexa account. One last thing I want to show you here is actually where you hook the Lambda function from the developer portal. Actually, to hook it, well, it has not been refreshed. Let's refresh it. OK, perfect. It hasn't. So here, as you can see, I have been specifying an AWS Lambda function, correct? So this function got deployed on AWS. And here I can see on the default region for my service endpoint that my Lambda function is up and running and is available. So that is for the developer portal port. Now, let's have a look on the AWS console right now. What happened on this console? When I deployed the skill, actually, you can see here, if I can zoom a bit, that actually this morning, 3 hours ago, I deployed just a backup version, just in case I had any trouble. But a new Lambda function has been deployed a minute ago. Great. Let's have a look at it. Actually, as you might be aware of, when you have a Lambda function, you need to have a trigger set up to ensure that this function can be called and the different Lambda container can be launched. So it's event-based. So we've got a lot of different triggers, and by default, by using this Alexa CLI, it will already define the Alexa skill kit trigger for you. But also, it will already set up the CloudWatch log for you. So here we can see the Alexa skill kit trigger, the CloudWatch log, and also for AWS Lambda, as you might be aware of, to ensure that a Lambda function can be executed, it needs an IAM role, Identity and Access Management role. With no role, no Lambda function can be run. And if we look a bit more down, by default, when you create a Lambda function here, using the Ask console, you can see that it has created a Lambda role. And the role created, actually, here, let's have a look at the role. It's this one. It's a basic Lambda role, which will allow you to have the right to execute the Lambda function by itself. So it means that by using this console, this CLI, sorry, and once you have deployed the skill, you will be ready to use your skill out of the box. So once we have said all that, it seems that we are pretty much ready to test the skills. So to test a skill, of course, we have different manners when we are in the development process. Of course, we do have our device. But also something which is quite neat is that from the developer portal, but it's also true from the CLI, console line interface for Alexa, that you can simulate by simply inputting the text that you would have said to an Alexa-enabled device. So for example here, on the English GB, so meaning for the UK here, let's say I want to open City Guide. Well, then in that case, you can see that the skill did receive a JSON input that you can see on the left side on the screen, and actually the skill did answer with a JSON response. That was the code from the Lambda function that we have been deploying. And the blue box is actually what Alexa will say on the device. And if we look a bit step back and we have access to CloudWatch logs, let's have a look at the CloudWatch logs. Here, actually, you can see that a new log group has been created for this new function. And why I'm showing that is that because we've been added as interceptor for the request, but also for the response, to have an understanding of what the skill service is receiving as input and what the skill service is outputting as a response. And here you can see there, which actually, that a skill is simply receiving this JSON payload. And the skill simply needs, so as to speak, to process this payload. As you can see here, it's a launch request because I open my skill, which happen on the UK local. And after, there is a lot of other information, like, for example, my user ID and the session that has been created when I invoked my skill. In the same manner here, if you want to look at the response that have been sent by the skill backend, you can see here that the envelope sent by the skill is available right there. So it's quite neat to use that in terms of debugging. So just to give you a bit of insight of the different way you could use different AWS services. And now let's just, for example, open the skill. Alexa, open City Guide.
Welcome to Gloucester Guide. Say about, to hear more about the city, or say coffee, breakfast, lunch, or dinner, to hear local restaurant suggestions, or say recommend an
Alexa,
attraction, or
recommend me an activity.
Try Rockport, which is 4 miles away. Have fun. A quaint New England town, Rockport is famous for rocky beaches, seaside parks, lobster fishing boats, and several art studios.
So here what happened? Remember, on the slide, we've been saying that the different iterances that a user could mention, like, for example, recommend an attraction or recommend a restaurant, this kind of interaction. So this iterance has been processed and you're served by Alexa, and this iterance has been transformed to an intent. And if we stay on CloudWatch here to see actually what your Lambda function did receive, let's see here, up. So here actually, when I ask Alexa to give me a recommendation for an activity, I did receive from my backend, from my Lambda function, a JSON request here, which is an intent request for an attraction intent, the one we've been seeing previously on the developer portal and on the JSON file from my laptop. But we did not specify any distance yet. So I think it's good, but maybe you want to add something else, which is to have persistence on the backend level. Why? Because at some point, you have different level of persistence from Alexa request and response behavior. You've got the attributes from the request itself. They will be lost after the request ended. Then after, you've got the session attributes. That will be the attributes that will stay alive from the moment the session is open until the moment the session ended. But it seems at some point when the session is ended, you will not be able to persist the different values that you want to use on not a daily basis, but to ensure that customers will have a nice returning experience. So in that case, one thing which is quite good is to use DynamoDB as a persistence layer. And how we can do that? Thing is, here, if we go back to our SDK, and I'm not sure we have time to do it live, so we will use actually our backup here, which is the City Guide backup, which is actually pretty much exactly the same thing as the previous round, except that I added it with DynamoDB enablement. So how to do that? Let's have a look here. Up. Okay. So here we are on the Lambda function used for the skill where I activated DynamoDB as a persistent layer. How to do that? Same thing here, we will use the Ask SDK, using the Ask SDK lib this time. And actually, if we look at the moment where we will instantiate this instance of the skill builder here, there is two little things that I simply need to add, which is actually, I want to be using a DynamoDB table called mySkillDDB table, and I want you as a skill, as a Lambda function, to automatically create this table. And then after, how will I be able to persist the different attributes I want? Just let me find here. Okay, it will be easier this way. I will be using, yes, the attraction handler. Here, at some point here, what I will be doing is actually to gather the attributes from the session, and oops, it's not the one I wanted to show you. Sorry about that. Okay, so here actually, if I want to persist some attribute, I will take the attributes from the sessions and all the different session attributes that I have defined. Here, for example, I'm doing a type of research with a restaurant for a diner. Here, I will simply call my attribute manager here, which comes from my under input, and set the different attribute I want to persist and save them to DynamoDB. That's the only thing I need to do. And the fact to be using a persistent layer will also allow me that when a user will use again the skill, I can change the different prompt. For example, when a user is opening a skill for the first time, I can say, welcome to the Gloucester Guide. When he comes back, because I know the user have already been using my skill, I can say, nice to see you again, because the user is known from my skill using their user ID. So let's have a look at what it looks like here on the developer portal. So on my backup, actually, I've just changed the invocation name to be Dynamo Guide, just to show you the difference. And I've also added a last search intent, because I do persist in database the different attributes regarding a user I've made as a search. So once I go back to my skill, I can know what type of research have been done by a user. So let's say, for example, we try it. Alexa, open Dynamo Guide.
Nice to see you again on Gloucester Guide. Tell me what you need, say about, to hear more about the city, or say coffee, breakfast, or dinner, to hear local restaurant suggestions, or say recommend an attraction, or say go outside.
Pancake is what I need.
For breakfast, try this, George's Coffee Shop. Would you like to hear more?
Alexa, stop.
Okay, see you next time.
So here, actually, the last search I've been doing here, as you could see, it's for breakfast. So let's say, for example, I want to invoke one more time my skill to know what was my last search. So Alexa, ask DynamoDB what was my last search.
You're searching a restaurant for breakfast. I recommended you George's Coffee Shop. What would you like to search for? An attraction
Alexa,
or a coffee shop?
Stop.
Okay, see you next time.
So here, actually, if we look a bit more at the DynamoDB table which has been created here, and we look at the different items, here you can see that I've got two different users here. I've got user 1, where the key is the user ID here, and actually, you could see the last search that have been made, which is to do a search on coffee for restaurants. So that is pretty much how you will be able to use DynamoDB, by simply specifying on your Lambda function the fact that you want to enable DynamoDB using the Alexa SDK. And finally, if as a wrap-up of the session is just to wonder actually when to choose voice. So when you want to choose voice, actually you will be choosing voice where it is easier, faster, and more natural to be used. For example, if you think of a way to switch on or switch off the light, the modern way is to use a smartphone to locate the application, to switch on or switch off the light, then after to lock your smartphone and put it back in your pocket. If you simply use an Alexa-enabled device, in that case, you simply Alexa, turn on the light or turn off the lights. So always choose voice when it is more natural to use. And if you'd like to go further and have a bit more of understanding of how to design for voice, please join me tomorrow at the Apollo room. We will be saying how to design for voice for Alexa. And if you'd like to dive deep a bit more about how to make skills, here are the set of different resources that you can be using, actually, and specifically dedicated for the German team here. So that's why the first one is for Germany. And if you do have any question, we are just next to the giant Echo booth, so feel free to come and see us to have a bit more detail about how to create a skill. And thank you very much for your attention.